Well, the first thing I thought would be nice to have is some kind of GPS stabilization in flight so I could kind of let go of the sticks and manipulate my camera, but I decided to go with a Vector because it was so easy to install. I basically just unplugged my CC3D, plugged in my motor wires and connected this thing to the power. And everything goes through the power sensor. I got tied down right here, and it comes with a pre-fabricated wiring harness. And there's a little plug, 3D servo plug, 3-plug servo plug for your camera, another one for your video, and then you got a little 12-volt outlet here, and then buried down here we got a little 5-volt. So if you need different voltages, they're available, all filtered and regulated. I'm just going to be using these two, of course, for the camera and video. And then I'm going to splice in, or I'm going to tap in right here and get my 12 volts for my my gimbal. Well, this is probably the Blackout 330 configuration you're all familiar with. You just zip tie your camera on there and you go to town. If you have I've already taken my flight camera off, but it fits on another housing that builds it up even higher. It gets kind of unwieldy, so I've already stripped that off. All right, when you buy the Blackout recommended gimbal, which is I think a Martinez board from Hobby King, and I did that. You got to buy another top plate to mount it, and then we'll talk more about this one in a minute, but it mounts kind of up in the front, and I did all of that. And I got to tell you fellas, that Martinez board is a piece of trash. It doesn't hold horizon very well, constantly drifting. You basically shove your board up inside of there and you bolt the mount right up here in the front. Now if you take a look at this, get that zeroed a little better. If you take a look at this, when you mounted the Martinez board, it throws all of that weight way forward to the center of balance. So it turns what's usually a pretty nimble flyer into a pig. I just wasn't happy with it. So I tried to figure out a way to incorporate a quality gimbal like this Phatek G3, we'll talk more about in a couple of minutes, and also not have to mess around with that way forward center of gravity. So let's get to it. We're not going to need any of this top plate stuff. We're not going to need Blackout's $15 adapter board. We're just going to make our own. So let's strip all this off and I'll show you how we're going to do it. Alright, a lot of guys have already done unboxings, and this is all the junk that they put inside it. We're not going to use, these are all the mountings for different quads. We're not going to use any of that stuff. What we really want to take a look at, before we get too wound up, let's look at the Phatek. The reason I chose this Phatek G3, this is the 2-axis model, is because all of the controller boards are built into the housing. There's no external board. This is the only plug that comes out, and it plugs into another piece of hardware, this one. Now, I don't want to use this. It's one extra piece of weight, all these wires hanging out there. I just want to use the gimbal with that 4-plugger. So what I've had to do is trace all of these wires. And so we have power coming in on this jack, and then we have, to ignore the ground, and then we have 2 different channels, one channel for yaw, one channel for pitch. And when we jump over to this cable, this is the only output cable. Now let me tell you the advantage of this board, and that advantage is right there, that little diode. So if you accidentally plug your plus to your minus, and your minus to your plus, in other words reverse polarity, this little diode will protect you. So by getting rid of this board, that's the risk that we're going to take. We can't afford to cross our power cables, so we've got to be real careful about that. So when we look at this, I traced all of these with the volt ohm meter, and you're not going to be able to see it on there, but I've got a small diagram here. So when it's oriented like this with the opening on the top, and there's our opening, the farmost right is negative and positive, and then we have the 2 channels that we need to worry about. One of them is white, one of them is red. I don't know which is the pitch, which is all I want. One of these is the roll. I'm not going to bother with a roll. I just need to know which one is a pitch. So let's go ahead and connect this. Now I'm going to have to cut this wire. I'm going to cut it about right there, just in case things go awry and I've got to put it back on. I've got some leads to work with. But I'm going to convert to this 4-plug cable. I'm going to plug it into here, and that way it'll be very neat and I can unplug it very easily. And more importantly, this only goes in one way. So that's my insurance that I won't cross my power plugs. Okay, well, how are we going to do this? Let me get this stuff out of the way here. I want to take this gimbal and mount it something like that, as far back against that housing as I can get it. And that way it moves my center of gravity back quite a bit. Now, unfortunately, there's no neat way to do this, so we need to make our own little cradle to hold this. You want to keep it light. So I've got a sketch here. I drew a sketch, so the bottom is just a little holder, and then there's a stop on the back that's going to stop it from sliding too far. And there are all my measurements. So let me go ahead and put this into the SolidWorks, and let's draft something up that kind of follows these measurements. Just a little cradle. We can rotate it around here. You can get a better look of the 3D image. So that's the little stop, so the servo motor doesn't, or the gimbal motor doesn't slide too far, and it's just going to sit inside of this little cup, and we'll bolt it down on the frame. So let's go ahead and take this, and I'm going to print it on a 3D printer, and let's see what we come out with. Alright, here's what we got. These this is the exact sequence that it came out of the plug. So I've labeled it. So out of that plug, as we thought, we had plus and minus. That worked out perfectly. Please don't reverse those or you're going to burn up one of your servo motors. And then the white one, or the third pin, is your roll, and the last pin is your pitch. And you can see that's what I've got here. I've got my ground hot. I skipped a pin because I didn't want to hook up the roll, and then my pitch. So let's go ahead and bolt this thing down and get it working. Created another one. This has double-sided 3M. It's like moon gel. This is what it looks like. It's a clear material, sticky on both sides. So I'm going to leave it covered right now, and our gimbal motor fits in there just right. Now we've got to figure out where to mount that, and I don't want to mount it too far back because I don't want to bounce against this frame. This is what's called the clean frame. In other words, it's isolated from the bottom, vibration isolated. So I'll take a ruler and push him back about like that. Now he's kind of lined up with the front of those slots. So what I'll do is take my ruler and find an X-Acto, and I'm going to put a scratch right here. And I'm going to cut this front part just completely off and then round these edges. Right, that's the hunk that we cut off. Go ahead and sand this so there's no sharp edges. And then we're going to put this up here. Before we do that, I've put a piece of that absorbent material on the bottom. And I'm going to put my ruler up there. And I want to get him just as centered as I can. Now you'll notice there's some screw holes on the bottom. We're going to use those to, let me mount this real quick, to drill from the bottom and put in these M3 screws. So it's not just the adhesive holding this. Actually, there's going to be a few turns of this thread holding this on as well. Alright, we got those two M3s put in there now. They are not snugged down all the way. You can see a gap, and that's because I don't want them to directly transfer the vibration. So this thing is really adhered by that moon gel stuff, and then the screws are really to keep it from falling off. Alright, let's get on with this. I want this thing to go on here just about like this. Now it's not going to stay on just with the bottom. I need something along the top here, and since Valutech was considerate enough to give us these two screws, let's go ahead and use those two screw holes. Okay, again with the art, I am going to design something like this. So these two countersunk holes are going to use these existing bolt holes, and these two screw holes here are going to go into the top of our gimbal motor and hold that thing from the top. Alright, from concept to reality, just about an hour. Everything turned out pretty well. I've got it hooked up to the radio control, so the tilt, everything works exactly the way I hoped it would. In fact, let me tilt this up. When I turn the quad, just perfect. Absolutely perfect. I'm very happy with this Valutech. Now, something I don't know, I discovered this halfway through my design. I thought, you know, I'm going to make a slight change. And I put a 10-degree angle on this. And the reason I did that is so that when I take my camera, I got a little piece of tape on the bottom, I hope it sticks. My camera is now tilted about 10 degrees up. So while it's level, I'm going to be looking above the horizon just a little bit. I'll still be able to see it. But when this thing goes into high-speed mode, rather than staring at the ground, now it's going to be looking straight forward. So maybe I can avoid some of those power lines and trees and fences that I'm always crashing into. Anyway, this thing was a lot of fun to build, just a real kick. It doesn't take very long, and it'll be even less time for you because I'm going to make the entire mount available on Thingiverse. I'll put the link down in the description. I'm also going to make, this is already on Thingiverse, I'll put the link for the camera case in the description as well. Anyway, fellas, thanks for your time. Appreciate it.